Afternoon, good evening, and welcome to this webinar on how to AS number properties. In this webinar, we will be focusing on one particular topic, that's divisibility and remainders. And one of the basic foundations of divisibility and remainders is prime numbers. So to make sure that you guys are well prepared for this webinar, we did send a couple of video lessons your way. They are on prime numbers 1 and 2. If you have not gone through these video lessons, I would recommend that you go through them. They would multiply the gains that you would get from this webinar. So these video lessons are part of your free trial. If you're registered for this webinar, they were also sent to you as a part of the post-registration process. So make sure that that you go through these video lessons by just logging into your free trial. If you're a paid student, of course, they are in the number properties course. Now, we have some upcoming free sessions. We have a free webinar on GMAT reading comprehension that is next Saturday. Very similar to the webinar today in quant, we'll start from the very basics in that webinar and build upon those basics to demonstrate how GMAT RC is more about reading things properly than about being a voracious reader. And if you follow certain reading strategies, how you can comprehend the most complex passages that the test would throw at you. Then next Sunday, which is exactly a week from now, we have a quant workshop. Think of this workshop as a proctored quant test, and in which we not only tell you what your current quant score is, but we also tell you what are the areas that you need to focus on, as well as what are certain habits that that are causing you to make mistakes. Again, if you've not registered for this one, please do so. With that, since this is a free webinar and since it's quite heavily attended, we do ask a certain set of leading questions to understand the makeup of this group. The first question that we ask is, hey, when do you plan to take the GMAT? The second is, what's your current quant score out of 60? And then the next one is, what is your target quant score? And again, that's out of 60 as well. And by the way, if you've not responded to the first one, please do so. All right, based on the data that I have over here, but 45% of you haven't taken a date as of yet. 30% of you are planning to take the GMAT in about 45 days to 2.5 months or so, so 45 to 75, or 46 to 75 days. Presumably, this means you're going to be applying for round 1 of next year. And then we have about, say, 22% of the class, 23% of the class who are going to take the test in the next 45 days or so. Then with regards to the current quant score out of 60, what I can see is about half the class is in that less than 40 bucket. And then we have more or less an equal distribution in the 40 or 41 to 42, 43 to 45, until there are a few folks who are even scoring higher than 48. With regards to your target quant score, Q50 and Q51 account for about 80% of the class. If you add Q49, that's about 90% of the class, give or take. Now, as I said earlier, we're going to focus just on divisibility and remainders, and my goal today would be to make sure that for these two topics, you get to that 90th percentile, you get to the equivalent of Q49, Q50, or Q51 just for those topics. And I'm going to demonstrate that if you go through a process of focused learning and application, you can go from someone who's at a 30th percentile to someone who's at a 90th percentile in a matter of 4 to 5 hours on one focused topic. And if you apply this to other set of focused topics, you can really achieve the same outcomes. Having said that, I want to ask this one other question. How many of you, and let's kind of get a yes/no poll over here, how many of you, right, have a personalized study plan that you're working off of? Select yes if you have a personalized study plan, select no otherwise. Okay, the question is, how many of you have a personalized study plan that you're working off of? All right, about 60% of you do not have a personalized study plan. So I'm going to take a couple of minutes just to really tell you how to get one, because I want to make sure that each one of you gets a personalized study plan. So we're now in what we call as a presentation pod, and And then you should be seeing a presentation that says number properties 2. So very quickly, I'm going to go through what are the various steps to go through a personalized study plan. So if you want to get a personalized study plan, you have to do three things. One is you have to figure out where you currently are, which we call as quantifying your starting abilities. The next is you've got to define your target milestone. So depending on the target score that you have, these target milestones over here will tell you a standard a target quant and a target verbal score, and this has to be personalized for you. Beyond that, it'll also tell you a target score for arithmetic, algebra, and so on and so forth. And then once you've done that, you need to make sure that you focus on learning the right things. For example, if you're already at 70th percentile in let's say number properties, there's no point studying concepts and number properties over there. So again, this is really important that you have this personalized study plan so that whatever energy you spend is spent on productive effort, is spent on areas that lead to score improvement. So let's see how you can define those starting abilities. The best way, frankly, the only way today to do this is by taking a sigma x mock. Why? Because this is the only mock that tells you what we call as your subsectional ability. So when you take a sigma x mock, it tells you where are you in sentence correction, where are you in arithmetic, where are you in algebra, where are you in geometry. So you get a percentile score for these abilities. Okay, and you can take a sigma x mock by just either typing sigma x mock or going to this URL. And if you ask a question in the Q&A pod, Manas would be happy to share this URL with you. The next thing you have to do is you have to set milestones which would lead to you getting to your target scores. And the way to do that is by going to our PSP or our study planner tool, which we call as GMAT Planner. So what is this? It's an AI-driven utility that empowers everyone, each one of you, to build that personalized study plan. So it takes in your current quant and current verbal scores. You can really see this is essentially the screenshot from PSP. And then based on your target quant and target verbal score for this one, it's for a score of 720, as you can see over here. It tells you what should be your target quant and target verbal score. And then from there on, it tells you what should be the target abilities in arithmetic and algebra geometry and various subsections in verbal to reach that V38. Now, remember, these 5 values are personalized to your starting abilities. So the tool looks at an array of about 50 possible combinations for each score and tells you which is the best means to getting there. And then from there on, essentially it tells you, okay, these are your starting points, these are your ending abilities, and then it creates that personalized study plan for you where you figure out, okay, this is the amount of time you're going to spend in SC, this is the amount of time you're going to spend in CR, and so on and so forth. The personalized abilities link is over here. And again, so you get this personalized study plan from, hey, this is where you're starting this is your starting score, these are your ending scores, and as you achieve these milestones, as you hover over this part, you'll see the score improvement that you've garnered. Okay, again, you can see the starting milestones and the target milestones over there. So when you do this, your entire GMAT preparation is divided into a sort of 5 mini preparations. If you hit these target ability levels, there's no reason why you would not hit your target GMAT score. So and then you also get your study plan, and it takes into account the amount of effort you're going to put in every day. So this is the amount of effort you put in on a weekday, this is the amount of effort you're going to put it on a weekend, and it gives you a day-by-day plan. Okay. So Ankur says, how many weeks does one need to get to a 700 score? Ankur, it depends on what your starting score is. If you're starting at a 600, you probably can get there in about a month and 2 weeks. If you're starting from a 500, you probably need 3 months. So again, if you go to gmatplanner.com, you can really figure out how to build a personalized study plan for yourself. Okay. With that, let's start with the crux of this webinar. By the way, if you want to stay updated with all things e-GMAT, you can connect with me on my LinkedIn. I have upwards of 14,000 students who are connected with me on my LinkedIn. All right. So with that, let's get to the crux of this webinar, which is to help you ace divisibility and remainders in number properties. So in this session, what I want to prove is that the key to acing GMAT quant is to make sure you understand the fundamentals and you have the structured approach to solving each and every question. And so what we're going to do is I'm going to give you 3 data sufficiency questions, and this our goal would be that by the end of this session you should be comfortable solving each of these 3 questions, at least 2 out of these 3 questions, in a very simple fashion. So so I'm going to give you these 3 questions. Then what's going to happen is we're going to start from the very basics. So because they're difficult questions, many of you are likely to falter on them early on. But what I want to prove is that even for such difficult questions, if you have the basics right, you know, you can get them correct and without even doing the math. Okay. So after we solve those 3 questions, we're going to do some warm-up questions. So these are going to be very simple. Then we're going to do some problem-solving questions. Then we're going to do some, which are 650 levels. Then we're going to extend that to 700 level problem-solving questions. And then we're going to repeat the data sufficiency questions in the end. So again, with regards to the number of questions and what we are called, you can really see that over here. So warm-up questions, that's very basic. The first set of problem-solving questions, we do 3 questions, 650 to 700. The next set, 700 plus problem-solving questions, we're going to call them Q4 to Q7, and then towards the end, we're going to repeat the Q8 to Q10. So is each one of you ready to solve these questions? Let's get started. Let's do a yes/no poll. Is each one of you ready? All right. And then, so get a pen and paper if you need to, although the more appropriate response should be get a whiteboard today. All right, so the way we're going to do this is we will do this thing called where we do still solving. Okay, so I'm going to share this poll with you, and you have to select still solving. I have about 211 students in the webinar, and I want to make sure that I get at least 130 people saying still solving over here. Okay, let's get 130 people to say still solving, guys. I have about 90 folks who've said chosen a choice. So the purpose of this is when you say still solving and then you choose another answer choice, then I know that you've done solving and I call time. So that way I am not going to call time. You as a group are going to call time. So I'm going to show the question once I get about 120 odd responses over here. 120 people saying still solving. 117, 118, 19. Okay, perfect. Let me remove broadcast results. And here is your first question. Guys, time's up. Get those answers in. 5, 4, 3, 2, and 1. Let me end the poll and let's broadcast the results. Here's how you guys polled. Now, one thing that says if you're in this webinar, participate. Why? Because that's the best way you're going to get feedback that's personalized to you. So participate if you're here. Even if you make a mistake, you'd know where you made a mistake. All right. So we're going to go to the next question, and I want you to again select still solving. So here is the next one. Select still solving before I show the next question. All right, let's get to 120 people saying still solving before we do that. I'm going to clear the timer to 0%. Actually, it's not 0%. All right, I have 120 people. Here is your next question. This is question 9. Guys, 80% of you are done. So let's get those responses in. 5, 4, 3, 2, and 1. Let me end the poll. And I'm going to broadcast the results. Okay, we got much better participation. 182 of you responded. That's good. You can see how you guys polled. Okay, with that, we're going to do the last 700 level question before we start into the learning phase, before we get into the learning phase. So I want you guys to select still solving. All right, let me clear my timer. 0% done. 84 of you have said still solving. I want 120 of you to say still solving. Okay, 3, 2, oh, perfect. Let's get here. All right, guys, 70% of you are done. Let's get those answers in. 5, 4, 3, 2, and 1. Let me end the poll. I'm going to broadcast the results. So again, we see that this various answer choices are popular, but choice D is a clear winner over here, which wasn't the case in for the previous webinars, for the previous questions. I'm sorry, but I want to thank you for that amazing participation. This is incredible. We had 171 responses for this question. That's great. Now, I know a few of you faced audio issues, and my apologies for that. Adobe Connect usually is a fairly reliable tool, but we've seen unprecedented traffic. And if you're on a slightly weaker connection, you may face some audio issues. Just join again, and the problem usually sorts out by itself. Uh, we love Adobe Connect because of all the flexibility that it allows us with polling and the various kinds of polls, which unfortunately other tools don't allow. So So again, my apologies up front. We want to make sure that the experience is as good as possible, and we're going to work with Adobe to fix that for a few of you who faced audio issues. Okay, so with that, we did the challenging questions. Our goal is to make sure that each one of you is able to answer these questions. Now, to do that, we're going to build we're going to go from the very basics, and now we're going to do what we call as the warm-up section, where we'll actually have you solve some very basic questions. Okay, uh, then the goal over here is to make sure that you get started on that unified path, and if you have some missing um, conceptual gaps, we give you feedback on that. For every question, we're going to provide a quick solution, not an explanation, to the same degree that you'd expect from e-GMAT. Again, this is something that you should know. This is just a revision, and for those of you who already have some sort of a foundation in this revision should be sufficient. So for 90% of you, it should be sufficient. For 10%, I think you'd need more explanation. If you need so, go back to your e-GMAT account and revise the appropriate concepts. So with that, let's get started. And Deepak, thank you for giving the feedback that the audio quality is better on the app as compared to the web. That definitely helps. Okay, here's your first warm-up question. I'm not going to say still solving. I'm going to really just wait for about 120 odd responses for the first. So don't worry about still solving, guys. You have the question. Start solving the question. And as soon as I get 100 plus responses, I'm going to start calling time. Right, 90% of you done. Let's get those answers in. 3, 2, and 1. Let me end the poll. Let me broadcast the results. And over here, 70% of you more or less made answer choice B, which is the correct answer. So I'm going to quickly go through this. The question says Z is a 3-digit number whose digits are consecutive numbers, and then it gives you 3 statements, which says, hey, which one of these is the correct statement? And then essentially, which means you've got to read the statement first before you approach the question. So when you read the statements, you see that it's about divisibility by 3, and the rule for divisibility by 3 is that sum of digits should be divisible by 3. Hence, you really say, okay, let me represent Z as x plus 1, and x plus 2, and then you really say, okay, so let's kind of represent this over here. Now, you say, so Z is equal to 3x plus 3, and when Z is 3x plus 3, what you really say is, okay, if Z is 3x plus 3, then it's 3 multiplied by x plus 1, which means it's something that's always divisible by 3. All right, and as you guys have really said, it's always divisible by 3. When you look at consecutive integers, you start from 0 to 9. You don't go from 9 to 0, by the way, just to make sure you guys look at this. Okay, with that, let's go on the next question. I'm going to clear all answers. And again, basic question. Okay, I'm going to have broadcast results. So you guys want to put on still solving. Let's put about 50 to 70 still solving over here. And then we're going to go from there. All right, I'm going to remove broadcast results. Here is your next question. 80% of the class is done. Let's get your responses in. 3, 2, and 1. Let me end the poll. I'm going to broadcast results. Now, this is a classic case of a scenario where you have to look at a core skill that we call as consider all cases. Now, what's given to you? What's given to you is that Z is a 4-digit number whose digits are consecutive numbers. And again, we are testing divisibility by 4. Now, what does this mean? What's divisibility by 4? Divisibility by 4 implies that the last 2 digits should be divisible by 4. All right. So which means, hey, Z could be odd. If Z is odd, we know it's not going to be divisible by 4. Why? Because only even numbers are divisible by 4. So that doesn't work. Or Z could be even. Now, if Z is even, then the last 2 digits may be divisible by 4 or might not be divisible by 4. So let's consider the cases over here. So 3, 4, 5, 6. In this case, 56 is divisible by 4, and that hence this number is. And in other cases, 1, 2, 3, 4, 34 is not divisible by 4, hence 1, 2, 3, 4 is not. So your correct answer is that Z may be divisible by 4. So there's a chance that Z may be divisible by 4, and there's a chance that Z may not be divisible by 4. So hence choice A is your correct answer. Okay. Now we're going to go and solve the third warm-up question over here. Again, very similar principle, very simple. These are warm-up questions. Let me clear all answers. I want you to select still solving. All right, I have more than 50 people selected still solving. Considering that this is a warm-up question, here is your next question. Right, guys, I had the wrong poll over there, and thank you, Amruta. So please choose this. This is an option D too. All right, with that, pretty much everyone's done. Thank you very much. Let me end this poll, broadcast the results. 80% of you got this right. Essentially, it's divisibility by 8. So what's the divisibility rule of 8? The last 3 digits should be divisible by 8, which means when you look at the last 3 digits of this particular given number, they are 897. And when you divide 897 by 8, you get a remainder of 1. Which means the closest number to this that is divisible by 8 would be when you add 1 to it, or when you subtract 1 to it from it, which leaves us 896. You look for 896, which is choice C over here. How many of you approached this particular question in this manner, where you only worried about the last 3 digits? How many of you approached this in this particular manner? All right, that's very good. About 80% of you did that. That's great. Thank you. For those of you who actually did the actual divisions, make sure you understand the divisibility rule of a rule for 8. It's really important. These divisibility rules many times are a great time saver, and often if you don't know them, you'd probably not be able to answer questions. Okay, now we're going to go towards our fourth question. Um, let's select still solving. Okay, we have 75% of you selected still solving. Here is the fourth question. Right, let's get those answers in, but 90% of you are done. And my apologies, I should have removed broadcast results. That I think definitely had a biased, that added a bias to your responses over here. Now let me end the poll. Let me broadcast the results now. 75% of you got it right. Now, starting this question, we're going to work on a concept that we're going to use throughout this webinar. What's the concept? That your dividend is equal to divisor multiplied by quotient plus remainder. And this is, if you know this concept, you can pretty much answer any question that the test will throw at you. And we're going to just prove that in this webinar. So this is the concept that we're going to use. So what are you given? Which means you should be able to express in terms of 4, where you should be able to really say n is equal to 4 times something plus r, where r is the remainder that we are concerned about. Now, what's given to you? What's given to you is, and remember, remainder has to be always less than the divisor. Now, what's given to you? You're given n in terms of 204. What's that? N is equal to 204 times quotient plus 3. Now, what do you have to express n as in terms of 4? So what do? Let's start doing that. You really say, combining this, you've got to visualize this, and this is what we call as a process skill of visualization. We write 204q in terms of 4p, which is 204q is 4 times 51 times q, okay, which means you can write n as 4 times 51 times q plus 3, and you know that this term actually has a zero remainder. Why? Because it's 4 times something, so there's zero remainder. So the remainder that remains is 3, and hence your correct answer is choice D. Now we're going to go for our last question, and again I'm going to reopen the poll. I'm going to clear all answers. We're going to go to still solving once again. So the last warm-up question before we go on to real questions over here. In the next question, we're going to use the same concept. Okay, let's get to about 60 people saying still solving. 3, 2, and 1. Let me remove broadcast results this time. And here is your next question. All right, class, 80% of you done. Let's get those answers in. 3, 2, and 1. Let me end the poll and broadcast the results. So, very similar concept. We express, we're going to use the concept where dividend is divisor time quotient plus remainder. What we are given, what we are asked is, how can we express n in terms of 5p plus r, where the divisor is 5 and r is the remainder. Now remember, there's an implicit constraint over here, which is that the remainder must be less than the divisor. Okay, so what we are given is ns 205q plus 6, which means the same process scale of visualization. We express 205 in terms of 5, which means it can be written as 5 times 41 over there. So if you do that, you really say, okay, 205q is completely divisible by 5. So you might come to this conclusion that remainder is 6, which is about what 31 of you did. But remember, the remainder always has to be less than the divisor. Okay, and when you do that, you say 6 is 5 times 1 plus 1, which means your remainder has to be 1. All right, so which makes choice A as your correct answer. So with that, and again, you can see the implied constraint and the process scale of applying constraints. And then some of you uh, 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 actually used this to really took an example and did this, and that's okay in these cases. But as questions get more difficult, so if you want to solve 500, 600 level questions, that will work. But if you want to be able to solve 700 level questions, you've got to know this principle. Because if you don't know this principle, in those 700 level questions, doing the math would not be so easy. In many cases, it would be impossible to do the math. And if you, the only way you'd be able to solve these questions is if you follow this approach. So once again, 500, 600 level questions, it can be done. But when it comes to 700 level questions, if you start taking numbers, you're going to face real challenges over there. What does P represent? P represents the quotient over here. You can see this equation, dividend dividend is equal to divisor times quotient plus remainder. We have used the same representation over here. Dividend is n, your divisor is 5, and the quotient is p, and then r is the remainder. Okay, Brett, does it help? That's your standard form of your standard divisibility equation. All right. So overall, make sure you know these concepts. I mean, this was a warm-up section. This wasn't these weren't real questions. These were just to make sure that you have the concept in there. So you need to have 200% clarity on these concepts. If you didn't do well, make sure that you revise this. In fact, if you made a couple of mistakes during this warm-up section, make sure you revise these post this session. I'm going to share the PDF towards the end. Why? Because when it comes to the more challenging GMAT questions, they test the same concepts, but the level of application is much higher. So two things are important. One is that even though you're substituting, you can solve these questions by substituting numbers. Don't do that. Why? Because as questions become more challenging, you're not going to be able to do that. The second is that you should know why this works. You should know why is it when we say divisor is equal to dividend is equal to divisor time quotient plus remainder. You should know why that works. That clarity should be there in your mind, because if the clarity is lacking, you won't be able to apply these concepts. Okay. Now we're going to start with easy 600 level questions, and then we're going to increase the difficulty from there on. All right. So let's start with our first question. Let's select still solving. This is going to be an easy question. You'd be able to do it by doing the math. I would recommend don't do the math. Use the equation. Okay, if you use the equation, you're going to learn in a manner that's going to benefit you a lot more. Okay, I want to get 100 people saying still solving now, because we're going to more challenging questions. So I need a more representative sample data sample of folks. All right, I have upwards of 100 people who've said still solving. Here is your first question. As 80% of you are done, let's get those answers in. 5, 4, 3, 2, and 1. Let me end the poll. I'm going to broadcast the results. So 57% of you got it right, but I want you to tell me how many of you did the math to get to the answer. How many of you actually multiplied 30 with 8.2 to get to the answer? How many of you did the actual math to get there? I want to really get that data point, because that's the more critical piece, because if you know how to do multiplication, you can get to this, but that's not how I want you to do this. So be honest, tell me how many of you did the math. All right. But 60% of you did the maths. Let's see how I would get out of it. So I'd use the same formula, and thank you, Alex, for following the methodical approach. We say dividend is equal to divisor times quotient plus remainder. And I'm going to repeat this till you get sick of it, by the way. So essentially, we've got to figure out what's the remainder when m is divided by 15. So I really say, hey, m is equal to 15p plus r, where the remainder, the implied constraint is that the remainder has to be less than 15. What's given to us? We're given m in terms of 30. So we're told that m is equal to 30 multiplied by 8.2. Again, remember, always think about expressing numbers in this form. Dividend times divisor times quotient plus remainder. That's really important for you. So again, you split, you say 8.2 is 8 plus 0.2, which means m is equal to 30 times 8 plus 30 times 0.2. And the nice thing about this is you can now treat each of these terms independently. All right. So when you visualize this, you really say, okay, here is what I'm given, here is what I need to express it in. So I say, okay, let's express 30 as 15 times 2. So you say m is equal to 15 times 2 times 8 plus 30 times 0.6 is 0.2 is 6. So essentially, This part over here, because it's 15 times something, it leaves 0 remainder, and hence my remainder is 6. Now, those of you who made a mistake, those of you who made a mistake, where did you make a mistake? I mean, but 40 odd percent of you were made a mistake in this question. Where did you make a mistake? Those of you who chose either choice A or choice B or choice D or E. Can you type in your answers over here, please? Okay, expressing the equation. Fluffy is saying multiplying the remainder with 30. Okay. Okay, you thought 0.2 was a remainder. Okay, the remainder always has to be an integer. Couldn't visualize it this way. I like how you're using the word visualize, Sidra. It's really important that you do this. Okay. In expressing the equation. So now you know where you made a mistake. So what we're going to do is we're going to do a very similar question as the next one so that you can build upon it. So let's go towards still solving before I show the next question. Okay, let's get to 100 people saying still solving. 94, 98. Okay, we have 100 people who said still solving. I'm going to now show the next question. Here's the next question, very similar question. Use just the same. Almost 80% of you are done. Let's get there. 3, 2, and 1. Let me end the poll and broadcast the results. So the results were much better this time, but 73% of you got this right. So again, the same principle. We have to really express m in terms of divisor times quotient plus remainder. Now the difference over here is the divisor over here is 30. So why do we get 30? We get 30 from here and from the question statement. So we have to express m as 30p plus r, where r, remainder, has to be less than 30. Now what are we given? We're given that m by 15 is 8.2, which means we can express m as 15 times 8.2. Now, again, we follow the same principle. We rarely say m is equal to 15 times 8 plus 15 times 0.2. Why? Because 8.2 is 8 plus 0.2. Now, as we do that, we really say, okay, we visualize and we say we want to express m in this form, and we have a m in this particular form over here, where we have these two numbers, a and b. Okay, let me just make sure we point these arrows correctly. Now, so what do we do? visualize this and we really say, hey, we divide 8 as 2 times 4 and we say m is equal to 15 times 2 times 4, which is the same as 15 times 8, plus 15 times 0.2, which is the same as 3. 15 times 0.2 is 3. Okay. Then we really say, okay, that's 30 times something, which means there is 0 remainder out of this. So the overall remainder is 3. All right. So that's how we use a scalable approach. Of course, you can do the math and get to the answer, but that's not how we want you to do it. We want you to use this method because as questions get more challenging, you're going to see the utility of this method. Let's go towards still solving. Where does 3 come from? 15 times 0.2 is 3. If you do the math, you're going to find 15 times 0.2 is 3. Awesome. All right, I want 100 people to say still solving. 82, 86, 87, 93, 97. All right, I'm going to remove broadcast results. Here is your next question. All right, guys, 80% of the class is done. Let's get those answers in. 5, 4, 3, 2, and 1. Let me end the poll. Broadcast the results. 60% of you got this right. The answer is 18, but many of you were also confused with 3. So let's kind of go about doing this. Again, it's the same equation, but here we've kind of reversed the divisors. So we have to figure out what's the remainder when m is divided by 30 over here. So we have to express m as 30p plus r, where the remainder is less than 30. Now what's given to us? What's given to us is that m is 15 times 9.2. Now remember, this is what we need to express it in this form. So let's see how we go about doing that. We say m is equal to 15 plus 9 plus 15 times 0.2. Now, can we convert 15 times 9 into the form where equivalent to 30p? That's slightly challenging. So let's kind of do a bit more math over here. And we really say, okay, let's convert 9 into 8 plus 1. And again, 15 times 0.2 is this number 3 over here. We already know that from the prior question. So as we do this, we really say m is equal to 15 times 8 plus 15 times 1 plus 3. Okay, so we know 15 times 8 over here does not leave a remainder. Why? Because that's what we did in the last question. So the remainder is 15 times 1 plus 3, which is 18. You can see this worked out slightly better. Okay. So for those of you who faltered, and about 34 of you faltered here, where did you falter? Where did you falter? Okay, okay. But 90% of the class was done by the time I called time. Could not convert 15 times n into a multiple of 30. Okay. Did not get the split idea, lack of time. Okay, couldn't convert into a factor of 30. Again, that's where, so you still, the thing which is there is what you see is we're still using the same formula. So you're not lacking on the concept side. Where you're lacking is this visualization, and that's a core skill that we have. It's one of those 6 process skills that you need to master. And this skill is not as much about math as it is about, hey, thinking about that skill in a fairly explicit fashion. Okay, and we've some with regards to process skills. Well, we have some fairly good videos that you can really use to learn what these process skills are. So, and for you to learn process skills, here's a list of videos, uh, close to about 22 videos for each of these process skills over here. All right, with that, let's summarize the first section. These were 600, 650 level questions. But you can really see what we did in this section is that we went in what we call as a progressive degree of difficulty. But we used this one concept where we said, hey, dividend is equal to divisor times quotient plus remainder. This is the only concept we're going to use. Okay. To solve questions of various difficulty levels, all we need to do is we need to be able to visualize. And again, in the first question, we really said, hey, m is equal to 30. We were given that m divided by 30 leaves a remainder 8.2, and we had to find the remainder, or m divided by 30 is equal to 8.2, and we had to find the remainder when m is divided by 15. And we expressed 30 in terms of 15 and got the remainder as 6. The second one, we actually had reversed this. So we had to figure out the remainder when m is divided by 30, but what we were given was that m divided by 15 is 8.2. Again, we expressed m in terms of 30 times something, and we got the remainder as 3. In the third question, we were given that m divided by 15 was 9.2. We had to find the remainder when m is divided by 30. And again, what we did was we split 9.2 as 9 plus 1 plus 8 plus 1 plus 0.2, and hence we got the remainder. Again, it's the same concept. It's the visualization that made this progressively difficult. Now, how many of you have started to feel comfortable with this concept over here? How many of you have started to feel comfortable with this? Okay, because we are going to actually just apply this going forward. Okay. Now, we're going to start solving 700 level questions over here. And we've already asked this question. So from now on, we'll build upon this understanding. Okay. And what we're going to talk about is addition, adding and multiplying remainders. It's a concept what we call as adding and multiplying remainders. So follow with me fairly closely. for the next 3 minutes or so. Why? Because I'm going to be building upon this concept to tell you some, you might call them tricks, I call them methods. Okay. So if you're given a question, what's the remainder when 31 plus 43 is divided by 7? There are two ways to approach this. And the answer to that is 4, but there are two ways to approach this. One is you really add it up and you get 74 divided by 7 over here, and you get the remainder as 4. But the second way, the preferred way that I want you to do is you divide 31 by 7 and you get 3. You divide 43 by 7, you get 1, and you just add 3 plus 1. Okay, that's the preferred way that I would do this. So the remainder of a sum is equal to sum of remainders. Do you guys get this? The remainder of the sum is equal to the sum of remainders. All right. Now, what's the constraint here? What's the constraint? Yes. Remember this, that constraint still has to be applied. Now I'm going to prove to you why this works, but remember this for now. All right. Now let's kind of look at what happens when you multiply stuff. And again, hold on. Let me just remove my annotations here. Now, what's the remainder when you multiply these numbers? Can you tell me what the remainder is going to be when you multiply 31 times 43? Can you type that answer down? Sorry about that. Sorry about that. I turned my audio off. So uh, uh, most of the time, sequence 2 is going to be faster. I was wondering why is it that you guys were typing, but now I understand. Thank you very much. Okay, so this is the approach that that I want you to take. Now let's understand why this works. And to when you understand why both these approaches work, you're going to appreciate the fundamental equation where divisor is equal to dividend is equal to divisor times quotient plus remainder. Okay, so let's understand how this equation powers adding and multiplying remainders. So again, the same numbers over here, and let me just bring in my short answer poll. Okay, and we really say, okay, what's the remainder when these two are divided by 7? What we do is we express 31 as 7 times 4 plus 3. We express 43 as 7 times 6 plus 1. So when we do 31 plus 43, what we are really doing is these two. We get these four terms. This term's divisible by 7 leaves 0 remainder. This term's divisible by 7 leaves 0 remainder. So the remainder of the sum is the sum of 3 plus 1. So that is why this works. And when you see this, you start to appreciate this representation even more. Okay. So now let's see why does it work in terms of multiplication. Just do the same thing. All right. So we express 31 as 7 times 4 plus 3. And when you read this, you say, okay, it's a term that's divisible by 7. That's a term that is not divisible by 7. Okay, and 43 as 7 times 6 plus 1. Again, a term that's divisible by 7. 7 times 6 is divisible by 7. And 1 over here is not divisible by 7. And you really say, okay, 31 times 43 is essentially 7 times 4 plus 3. So a term divisible by 7 plus a term not divisible by 7. Again, a term divisible by 7 and a term not divisible by 7. Now, again, follow closely. When you expand this, you get these four terms. There's 7 over here, so this is divisible by 7. There is 7 over here. So this is divisible by 7. There's 7 over here. This is divisible by 7. And then this one is not divisible by 7. So this is your remainder over here. Again, I'm going to let you guys absorb this. Or if you simplify this even more, you get this, and which essentially is the same form as 7p plus 3, and you get the remainder as 3. Okay, so again, this is how it works. All right. So knowing the fundamentals, the nuts and bolts, is that helpful? You can type your answers in the short answer part on the right. Okay. Okay, now let's get to the next question. So we're going to apply this. And here is where we are. Let's get to still solving. I want 100 people to say still solving. Let's get 100 people to say still solving before we get in there. 3, 2, and 1. Let me remove broadcast results. Here is your question. +80% if you are done. Let's get that answer in. 3, 2, and 1. Let me end the poll. I'm going to broadcast the results. Okay. choice C is popular, choice A is popular. We're going to solve both of these questions together. Actually, we're going to just solve this over here. So the correct answer is choice A. The answer is 0. And again, think about this. You're given a product of two numbers and you're asked what's the remainder when there's these two numbers. This product is divided by 3. You already know 24 is divisible by 3. So what should the product be? What should the product be? Well, what should the remainder be? I'm sorry. 0. Yes, 24 is divisible by 3. So if anything divided by 24, anything multiplied by 24 will also be divisible by 3. So the remainder will be 0. Again, the key takeaway, don't forget your basics. Just because I'm telling you all of these methods, make sure you remember your basics. That's really important. Okay. Now, had you even used the formula, the method that we talked about on the previous slide, you would have still arrived at the same answer. Why? Because what's the remainder when you divide 24 by 3? It's 0. Okay. All right. Let's get to the next question. Click on still solving. Three, 2, and 1. All right. Let's get to the next question over here. Here's question. %85 of you are done. Let's get those answers in. 3, 2, and 1. We end the poll. I'm going to broadcast the results. So 61% of you got this right. This is a 700 level question. And I can really see the progress over here, especially compared to the prior question. So when you think about this, you're given this expression 25 multiplied by 38 and a cube of this. It looks scary and you have to figure out the remainder when it's divided by 3. So when you consider this expression, you can really consider this expression to be a product of 25 times 8 multiplied by 25 times 8 multiplied by 25 times 8. So it's a so essentially it's a product of three numbers like this. Okay. So the remainder of each term can be calculated. So when I say each term, if you consider each of these to be a single term, you can figure out the remainder of each of these and they can be multiplied. All right. Now, considering that these three are identical, all right, and which means they'll have the same remainder over here, we can also do something like this. We can do 25 by 3 multiplied by 38 by 3 and you know, do a cube of this. Why? Because if the remainder, let me just get my annotation, the remainder over here is going to be r, the remainder over here is also going to be r, the remainder over here is also going to be r. Let me just move these remainders at the right position. So it's going to be r here, it's going to be r here, and it's also going to be r over here. So it's going to be r cubed. So we get the remainder of 25 by 3 and 38 by 3. We get 1 times 2, and then we cube this. 1 times 2 cube is 2 cube, which you get 8. But you know, you have this constraint, which is that the remainder has to be less than 3. So we express 8 in terms of 3 times 2 plus 2. And you get the remainder as 2. 61% of you got it right, which is really, really good. Okay. So let's do an overview of questions 4 and 5. So by using the sum rule and the product rule, we can really reduce the amount of calculation that we need. Why? We can say sum of remainders. A remainder of a sum is a sum of remainders. Remainder of a product is the product of individual remainders. Also, as we raise stuff to power, we can bring the number in and cube the remainder or raise the remainder to that power. The same principle also works, and that simplification is really important. Okay. Now, let's talk about another concept called negative remainders. And this is, again, we're building upon this concept. And sometimes it so happens that expressing a number as x plus y is not optimal, but expressing a number as x minus y is an easier way. Okay. The fundamental principle remains the same, that dividend is equal to divisor times quotient plus remainder. Okay, where the remainder has to be less than the divisor and the remainder must be positive. So there is the second implied constraint over here as well. All right. Now, there are two ways of doing this where we want to figure out the remainder of 5 divided by 2. All right, we know the remainder is 1. One way to express this is to really say, hey, 5 is 2 times 2 plus 1, and you get the remainder as 1. But then another way to express this, and the same way is if you do, 8 divided by 3, the remainder is 2. And how you go about doing it is you really say 8 is equal to 3 times 2 plus 2. Now, there's another way to express this. What if we really write down 5 as 6 minus 1, which means 2 times 3 minus 1, and 8 as 9 minus 1, which is 3 times 3 minus 1. Again, remember this. This is here we are still dividing by 2, and here we are still dividing by 3 over here. So that's what we are doing. And these are what we call as negative remainders. So we get the remainder over here as minus 1. But remember, our constraint really is that a remainder must be greater than or equal to 0 and must be less than the divisor. So let's apply these constraints and let's see how we convert these negative remainders into positive remainders. And again, Why we are doing this, you guys may be thinking, because in certain questions, this is a better way, and I'm going to explain this with certain examples in the next few minutes or so. So let's see how we convert a negative remainder into a positive remainder. So focus on this one. Remember 5, we had expressed 5 as 2 times 3 minus 1. So that's what we did. We said 5 is equal to 2 times 3 minus 1. Now, this gives us a negative remainder. So what we do is we add and subtract the divisor. Remember, the divisor was 2 over here. So we do a plus 2 and a minus 2. Why? Because in net, we are doing a plus 0, which is fine. All right. Then we rearrange the terms and we get 2 times 3, and we bring in this particular minus 2 next to this term over here. All right, and then we get minus 1 plus 2. So this is purely what we're doing is rearranging the terms. We get 2 times 3 minus 1, and then with minus 1 plus 2. Essentially, as we do this, we get the same thing as 2 times 2 plus 1. All right. We know this term's divisible by 2, so the remainder is going to be this part, which means 1 over here. Again, the same concept. This is just to explain why the concept works. Over here, also we express 8 as 3 times 3 minus 1, and then we add plus 3 and minus 3. Actually, remove the pole over here, move the pole over here. Again, we've added and subtracted the divisor. We rearrange the terms like the same way we did with the other case, and you get 3 times 3 minus 1, again 3 times 2 plus 2, and you get the remainder as 2. Okay, again, the concept of negative remainders really important when we deal with with certain visualizations. Now, the key thing over here is positive remainder is equal to negative remainder plus the divisor. So in both the cases, minus 1 plus 2 would have led us to plus 1, minus 1 plus 3 would have led us to plus 2. That's the concept that you need to remember to be able to apply this. So let's kind of apply this concept moving forward. I'm going to open the poll. I want you to select still solving. 5, 4, 3, 2, and all right. Here's the question. Let's solve this. All right, 80% of you are done. Let's get those answers in. 3, 2, and 1. Now, let me broadcast the results. 54% of you got this right. Again, remember, this is a 700 level question. Now, we're going to use two concepts here. One is the remainder of a sum is equal to sum of remainders. And what we know is this statement leaves the remainder of 0. So, essentially, we have to worry about the remainder of 17 to the power 7 divided by 3. Again, we do this. This leaves the remainder 0. So we have to figure out how do we get to 17 to the power 7 divided by 3. How many of you were able to get to this point? Okay, pretty much everyone was able to get to this point. That is great. If you're able to get to this point, you should have been able to get to the answer. Let's kind of look at this over here. Now, we use the concept of negative remainders. We say 17 is 3 times 6 minus 1. We know 3 times 6 minus 1. 3 times 6 is completely divisible by 3. You can also express it as 3 times 5 plus 2, but that's not what I would recommend that you do. Okay, so we get the remainder as minus 1 to the power 7, which is minus 1 because it's an odd power of 7. And you know a remainder can't be negative. So you say, okay, let me add the divisor to it. And you get the answer as 2, which is choice D. Now, 54% of you got this right. Those of you who made a mistake, where did you make a mistake? Where did you make a mistake? Those of you who made a mistake. Okay, thought you could leave it negative. All right, you can't. A remainder always has to be positive. Remember the constraints. If you did 2 into 2 to the power 7, you'd get the same answer, but that's not how I would recommend. It requires more math. 2 to the power 7 is 128, and 126 divisible by 3, and you leaves the remainder 2. 2 to the power 7 is 128, by the way. Okay, again, you're going to get the PDF. You'd be able to read through it. The PDF is very, very legible, by the way. So now that many of you understand this concept, we're going to solve another question using this concept because we want to solidify this. Vishwas says, why is it that 2 to the power 7 is not, or 15 plus 2 is not recommended? Vishwas, you're going to see this in the next question. So if you've not used the concept of negative remainders here, in the next question, you'd be forced to do it. So let's get to still solving, guys. Let's get to the next question because we want to after this, we're going to get to the next 3 questions, the last 3 questions that were there. Okay, let's get 80 people to say still solving. 80 people. 5, 4, 3, 2, and 1. Great. Let me remove broadcast results. Here is the last question before we go into those data sufficiency questions. %80 of the class is done. Let's get those answers in. 5, 4, 3, 2, and 1. Man, I love this. 700 level question, 75% of you got it right. That's great. That is really, really good. So how do you go about doing this? You express this. Remainder of sum is sum of remainders. You really say this is a 0 remainder. So I've got to figure out 17 to the power 7 divided by 6. Okay. You say 17 is 18 minus 1. Why? Because 18 is divisible by 6. So then you really say I've got to figure out the remainder of minus 1 to the power 7. Why? Because this term is completely divisible by 6, and which is minus 1, but a remainder can't be negative. So what do? I add back the divisor, convert it into a positive remainder. Voila, you get the answer as choice E. So now hopefully you guys can appreciate the concept of negative remainders. And you can really see the concept of positive remainders starts to become way more challenging. Perfect. I love when people use the term cementing. Sahil says if it's 17 to the power 8, do we still add the divisor? No, Sahil. If it's to the power 8, you don't add the divisor. Why? Because then it's a positive remainder. That's a great question, Sahil. So if this power over here, if this power were 8 instead of 7, you would get plus 1 over here because it will be minus 1 to the power 8. That's a great question, Sahil. Okay, now that you know this concept, we're going to start going into the data sufficiency questions, and you're going to find that if the question doesn't scare you, then you're going to find that you're going to have a much better hit rate with that question. Now remember, this is how we polled in the prior data sufficiency question. Okay, let's see how we poll again as we solve the same question. So let's get to still solving. Let's get to still solving. I want 80 people to say still solving. All right, I'm going to remove broadcast results. All right, the same data sufficiency question. Here is the question again. I want you to tell me what's the correct answer. Just to interrupt you guys, don't be biased as to how you polled, because how you polled earlier, you may have made a few mistakes. Focus on what we have learned and then solve the questions. pretty much all of you done. So let's get to the results. Let me end the poll, broadcast the results. This is how you polled. Now, this is how you polled earlier. Right now, 74 of you have gotten it correct. Choice A is the correct answer. Earlier, only 33 of you had gotten it right. So you can see the improvement over here. So let's see how we'd go about doing this question. Okay. So let's look at this. What's the remainder when the positive integer p is divided by positive integer m, where m is greater than 1? All right. So that's how we do this. And we're given two statements. We're given p is equal to m plus 1 to the power 8. And the second statement says m is equal to 8. All right. So what we have to find? We have to find the remainder when p is divided by m. All right, and m is greater than 1. There's not a whole lot that's given to us, but essentially at this point you should really say we have to express p in terms of m times k plus r. That's something that we want to really do. Now, what does statement 1 say? Statement 1 says that p is equal to m plus 1 to the power 8. So when we divide p by m, what do we get? We get m plus 1 to the power 8 divided by m and the remainder of this, which, as we've seen this, we can do m plus 1 by 8 by m, the remainder of that. And the remainder of that we've already seen is 1 to the power 8, and the remainder is 1 over here. Okay. And which means statement 1 does give the answer. Shinji is saying why 1? Because we did that. That's the concept of positive remainders. We just did that in question number 4, question number 5 and 7. Just we practiced the same concept in question 5 and 7 with actual numbers, and we did exactly the same. How did we figure out what was the remainder of 25 divided by 3 to the 25 to the power 7 divided by 3? That's exactly the same thing. We express 25 as 24 plus 1, and 24 divided by 3 doesn't give a remainder, right? Yep, that's exactly this. So statement 1 is sufficient. Our options are now either choice A or choice D. Let's now go towards statement 2. Statement 2 says m is equal to 8. Can I do something in terms of p? No, there's no information about p, which means statement 2 alone is not sufficient, which means my answer choice is A. All right. And again, for those of you who are struggling with this step, if you compare this to example 5 or example 6, okay, let me just do this. Let me just put in a notes pane over here, just for very simple stuff. Here's notes. I want you to tell me, let me just increase, and I'm going to do this. Six times, okay, let's do this. What is the remainder of 6 times 6 times 6? This whole expression divided by 5. What's the remainder of this? Let me get in the short answer pod over here. What is the remainder of 6 times 6 times 6 divided by 5? 1. How did you get that? You really said, okay, let me really just do 6 divided by 5 and raise that remainder to the power 3. And what I do, I really just say, hey, 6 is 5 plus 1 plus 1, and then I divide this by 5 and then raise all of this to a higher power 3. Okay, and which again is equal to 1 raised to 3. Yeah, the positive remainder played a role. Okay. If I change 6 to 7, yes, exactly. If I change 6 to 7 over here, then let's change 6 to 7. I'm going to copy all of this. Let's just do this, Omar. And if I change 6 to 7, and I'm going to just do this over here, 7, 7, 7, and I'm going to really and do the 7 divided by 5, and I would say 5 plus 2, and I'm going to say 2 to the power 3, and then which is going to be equal to 8, which is greater than 5. So what I'm going to do is I'm going to do 8 minus 5, and I'm going to get the remainder as 3. Does that help, Omar? The method remains the same. Okay. We've done all of this. This is just data sufficiency. Why is m greater than 1? Because anything divided by 1, the remainder is 0. Vikas. Was it Alex who really said that? Javed, why is m greater than 1? Because anything divided by 1, the remainder is 0. Does that help, Javed? Then it would be a moot point. All right. So let's go to the next question. The next data sufficiency question that we did, question 9. I want you to select still solving. 80 people to select still solving. All right, let's remove this. Here is the next question. And guys, I love how you're asking questions in the Q&A pod. You're creating derivative questions. Do that post this session and you're going to get the answers by yourself. But right now, let's focus just on this question. But 80% of you are done. Let's get those. Four, three, two, and one. Let me end the poll. So I see, I'm going to broadcast the results. I still see a lot of people. We don't have a clear winner here. I see a slight improvement over how we polled previously for this particular question. This is how we polled previously at the bottom. We call it question, where you see the question number is question 9. And this is how we poll currently. This is a classic case of applying constraints. If you don't process this question up front, you're going to find that it's difficult to solve this question. But if you process this question up front, you're going to find that it's very easy to solve this question. Okay, so what's given to you? What's given to you is that n is a positive integer, and we've got to figure out what's the remainder when 38 to the power n square is divided by 13. Now, how many of you were scared when you saw this and you said, man, this is challenging? How many of you were scared? How many of you were scared? Yes, no? Actually, let's get in a yes no poll over here. Let's just get, I love, as a company, e-GMAT loves data. So let's get a yay or a no, nay poll. How many of you were super scared or scared when you saw this and said, man, how the hell am I going to do this? It's n square. There's a power in a power. But half of you were scared. And remember this, fear prevents us from doing things, prevents us from using knowledge that we have. So when you are scared, one thing that I will tell you, or rather in the context of the GMAT, one thing that I'll tell you is you always have to trust the test maker. The test maker will not give you questions that are super complex. All right. Fear causes brain freeze. So let's kind of look at this. All right. So we have to figure out what's the remainder when 38 to the power n square is divided by 13. So before we even go into statement 1, there's a lot of information which is given in my original question statement, so which I'm going to analyze. So this is what we need to figure out, 38 to the power n square divided by 13, the remainder of that. So to do this, what's the first step we do? We express 38 in terms of 39. We use the concept of negative remainders. That's something that should have jumped at you right away. How many of you did that? How many of you did this and said, okay, I'm going to express 38 as 39, 3 times 13 times 3 minus 1. Okay. Now, don't try and do that. This will start to become super complex. All right. So essentially, when you do this, what is your remainder? It's minus 1 to the power n square. How many of you were able to get to this point? When you express 38 as 13 times 3 minus 1, your remainder is minus 1 to the power n square. The concept of negative remainders. Okay. Now, there are two possibilities that exist. One is if n is odd, then in that case, the remainder is negative. You've got to add 13 back. If n is even, then in that case, your remainder is positive. You don't need to add 13. So if the remainder is negative, you need to add 13 to it, and the final remainder is 12. If the remainder is, if n is even, the remainder is positive, and your remainder is plus 1. Okay. How many of you did this level of processing? This is the same concept of negative remainders. Actually, let's get the stats here. How many of you did this level of processing? I'm going to remove this one, and my apologies for having you to choose again. 60% of you did this level of processing. 60% of you should have marked the correct answer. Let's see where you faltered, because it's not the math, or 70%. So all you had to figure out is, is n even or is n odd? Okay. Okay, that's the only thing that we had to figure out. Now let's look at statement one. Statement one says n leaves no remainder when divisible by 4, which means n is equal to 4k plus 0, which means n is even, which means statement 1 is sufficient. How many of you were able to get this? Okay, if n is even, your remainder is plus 1. You know the remainder, that's good. Now, let's look at what statement 2 says. It says square root of n is divisible by 1 and the number itself. What do you infer from statement 2? What do you infer from statement 2? N is a prime number. Yes, n is a prime number. Absolutely. If square root of n is only divisible by 1 and the number itself, then square root of n is a prime number. Not n, square root of n is a prime. Okay. So what it means is, let's look at statement 2. It tells you that square root of n is a prime number, which means n is a square of a prime number. And what it really means is n could be equal to 2 square or 3 square or 5 square or 7 square. Okay. Now, if n is equal to 2 square, what is n? N is even. If n is equal to 3 square or 5 square or square of any other prime number, it could be odd. So can we figure out what my remainder is going to be? No, not with 100% certainty whether it's going to be even or odd. Okay, so statement 2 is not sufficient, which means choice A is my answer. So, where did you guys make a mistake? Didn't get that it was n square, positive, didn't break the question stem. Okay, and you can really see how and where you are faltering, right? And that's really important. That is really important. Can I explain statement 1 once again? Yes, statement 1 says n leaves no remainder when divided by 4, which means n is completely divisible by 4, which means n is equal to 4k plus 0, where 0 is the remainder, which means n is equal to 4 times something. Okay, and which means that n is even, essentially. Crystal. All right. Now, we are almost towards the end. So I'm going to actually give you the PDF for the next question, and you have the solution for this. But hopefully, you guys can really see that GMAT quant can be mastered. I mean, many of you were below a Q40 in this, all right? And since you were below a Q40, we started from the very basics, and now many of you are able to solve the most challenging questions. The key to acing GMAT quant is making sure that we follow some good habits, making sure that we follow a methodical approach, and as we're doing this, we follow it consistently. And this is the case with Krish, someone who's really good with quant, who's at ease with a Q48, actually, but was he got to a Q48 without much studying. However, was unable to improve beyond that. And again, he tried solving hundreds and hundreds of questions, and was unable to improve. The moment, and his problem was data sufficiency. The moment he realized that the reason he was making mistakes was not math, but these process skills where he wasn't simplifying, where he wasn't applying constraints, where he wasn't inferring information from the question, at that moment his score started to go up and he was able to get to a Q51. Okay. Uh, he stopped solving questions. Actually, to get to a Q51, he stopped doing the math, he started doing logic. And that's really important over here. Here's a guy who was stuck at a Q45, uh, followed the same approach, and got to a Q49. The goal, same thing, same process skills. Math wasn't a problem, process skills were a problem. The ability to understand why the math works was a problem. So for him, the key thing was, because he's already at a Q45, to figure out where he was lacking and then improve upon it. He's a current student at Wharton. He'll be graduating towards the end of this year. Okay. Here's a guy who went from a Q30 to a Q45. Again, for him, the key thing was to start from the very basics. So some of you asked me early on, how long will it take for me to improve? It depends on what your starting point is. However, if your starting point is, if you're faltering on easy questions, don't go towards difficult questions. That's really important. Okay. Again, Q30 to Q45, really great improvement. And then as a guy who improved from a Q38 to a Q50, he's also a current student at Wharton. All right. And the focus for him, the journey was a lot longer. Why? Because he had to learn, then he had to cement methods, and he had to achieve a level of perfection to achieve a Q50. All right. But again, the key over here was to follow a progressive approach. And remember this, if you have a Q45 or a Q38 or a Q40, Wharton won't even look at you. You need a Q48 or higher to get into Wharton. So focus on building these good habits. You can get to a Q49, Q50, or a Q51 fairly easily. GMAT quant or async GMAT quant is not about the math. It's a little about the math, but it's mostly about these process skills or these good habits that you need to inculcate. With that, I want to conclude this. I know we still have that 10th question. I'm going to share the PDF. The solution is there. Attempt it. We budgeted 2 hours for this session. I want to make sure we finish this in 2 hours. And people who want to get the PDF, I want to give them the PDF over there. One thing that we did not emphasize directly, but I want to make sure we get to it, is that when you solve a question, become an active reader. And the second thing is, when you see something complex, don't worry. Don't start to panic. Why? Because the test maker will not throw anything complex at you. Okay. You know everything that is there to be able to solve this. Good luck. Then and as next steps, log into the free trial, solve these concepts, and solve the practice question. There are a few additional questions in the PDF as well, and then you can also solve a few questions in Scholarium. Okay. I'm going to give you the PDF, guys. So you and the PDF is fairly self-explanatory. So that's something that you can do this. Could we have more sessions in other topics? We are building more sessions as a company. We are always doing new things. If you're an e-GMAT student, you're going to really see some sessions which are going to be just for you guys that will come up in the near future. So stay tuned. Also, if you're an e-GMAT student, make sure you start practicing using the whiteboard. All right. If we don't know for how long the GMAT is going to be available just as an online exam. So practice using the whiteboard. We've done as close an implementation to the official whiteboard as can be done. So start using that, and you're going to find it's really helpful uh, 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 when it comes to solving verbal questions. It's really helpful for most quant questions. Only a few quant questions is where we still have to figure out. But we'll be publishing best practices on the whiteboard over here. Okay. So you can, as you go into this playlist, you can see 3 questions that we've solved using the whiteboard. Within the next 1 week, you will see about 12 to 15 more videos in the same playlist. So, so if you subscribe to the channel, as soon as we post another video, you're going to really see this. One of the other things you're going to see is that as we that the implementation that we have is the implementation that you'd see on the test. The whiteboard floats beautifully. It's not a pop-up. It's not a separate window. You can see the question. You can resize the whiteboard. It's something that our engineering team did, and no other company has been able to do this. Is GMAT going to be a whiteboard only test? We don't know that, Barry, but one thing that I can tell you is that a lot of people have had good experiences. I know you guys here just uh, uh, negative things about the whiteboard, but based on, if you look at the debriefs of GMAT Club, if you look at what Stacy Koprinz has said about the whiteboard from Manhattan GMAT, she started with, she attempted the test without much preparation. She got a 740. We've had other folks who've gotten a 790 using the whiteboard. And one thing that you realize from this webinar is a lot of GMAT math is not about writing equations. It's about having those good habits and writing a few things down. Was there a free session on number properties one? No, that was a paid session, and that will be a paid session in a month or so as well. So we do a lot of free sessions, but again, remember, we are a for-profit company. We exist to help you ace the GMAT, and we are a 50% company uh, that just focuses just on the GMAT. So we do need to make sure we make some money. So, and one thing that you realize is, yes, you've seen many sessions on probably not prime numbers and divisibility, but to build a session like this requires a lot of thought goes into building a session such as this one. Why? Because you've got to look at the pedagogy. You've got to look at how to build something that's progressive. GMAT live sessions, they will start to come. Yes, so we'll have a paid version of the course with live sessions soon. Uh, and those of you who are our current students will get a fairly nice bonus out of it. I still can't commit on the timing, but that's something that will come soon. Sort of. Uday has asked a question after finishing the e-GMAT course. How do you revise things? Let me share a video with you. But if you write to the e-GMAT team, they can give you very specific videos as well. Okay, let's get to a few more questions over here. If you enroll into the e-GMAT course, do you have access to all the webinars? You do, yes. Can you apply for just the whiteboard mocks from the e-GMAT course? No, you can't. We sell mocks just along with our GMAT online course. So no, you cannot, unfortunately. What is a whiteboard? Let me explain to you what a whiteboard is. If you go take a look at this video, just it should be coming. You should be able to see what a whiteboard is. It's the new way in which you take the GMAT. That's the only way you can take the test till 15th of June over there. Uday, write to rajat@e-gmat.com, and I'm going to share some videos with you as to how to do strategic revisions. All right. All right, guys. If there are, where can you access PDFs of all the free webinars? You can, if you look at the recordings on our YouTube channel, the recordings themselves, the notes in the recordings have PDFs in there. So if you look at the description of the recordings, you should be able to download the PDFs. Okay, here is where you can really get that. And again, what is the whiteboard? You can really get it over here. All right, guys, with that, I want to thank everyone for joining me today. I also want to remind those, since it's the first 4 days of the month, we're still doing our monthly deal. So if you're looking to buy the e-GMAT course, make sure that you get the deal price. We do this deal only once a month. So if you want to get that deal price, make sure you do that. You can get GMAT online for $299 and verbal online for $199. So again, write to me if you're looking to purchase. All right. With that, I want to thank everyone for joining me today, and I look forward to seeing you on the e-GMAT platform. Once again, remember we have our YouTube live session is tomorrow by Tuhina. Let me actually share. Oh, this isn't the right PDF. Hold on. Let me share the link to that as well. As the link to that. For those of you who are looking to get into Harvard, for those of you who are looking to get into top schools, this is going to be a really great session. Why? Because INSEAD has the most challenging application that's out there. So if you've not registered for this session, do register for the same. And again, we also have these sessions next week, so you can register for these as well. And click on the register now button. It should take you to the respective landing pages and help you to do this. All right, and you can write to rajat@e-gmat.com if you're looking for the discount. All right. Thank you very much. Bye bye and have a great day.